For this problem, you're going to need to calculate the Reynolds number and the Schmidt number. To determine which of these formulas for J sub D is appropriate. Now the Reynolds number, if I switch everything to meters, it's 0.0016 meters per second is the velocity given here. The density is 997 kilograms per cubic meter. The diameter, this is based on the diameter of the particles, and those are 6.375 millimeters, so 6.375 times 10 to the minus 3 meters. And then all of that is divided by the viscosity, given as 8.72 times 10 to the minus 4th kilograms per meter per second. And if you check, all of these units will in fact cancel. And the Reynolds number is about 1.17. The Schmidt number is 8.72 times 10 to the minus 4th kilograms per meter per second, divided by 997 kilograms per cubic meter, and 1.25 times 10 to the minus 9th meters square per second. And so that is really very close to 700. So based on a Reynolds number of about 1 and a little bit and a Schmidt number of 700, the appropriate equation is this one. And in this equation, it's 1.09 divided by epsilon, which is the void fraction. So this is given as 0.436. And our Reynolds number that we found to the negative 2/3 power, giving the J factor for diffusion is 2.25642, carrying out extra significant figures at this point. Now, this is by definition the Kc prime over the velocity times the Schmidt number to the 2/3 power, or Kc prime is equal to 2.25642 times the velocity, again fixing the units, although this is the only term with units, so whatever units you chose to use ends up working, divided by 700 to the 2/3 power. And so the answer is 4.58 times 10 to the minus 6 meters per second. Now this is for Kc prime. Yes, you could go through and use the natural log of concentrations, but I didn't actually give you enough information to do that. So therefore we're stuck with that we must assume that Kc and Kc prime will not be all that different, which is correct if it's a dilute system. And so therefore 4.58 times 10 to the minus 6th meters per second is my answer for either Kc or Kc prime.